Welcome, I'm Lauris, and I'm going to explain everything that you need to know about the Ground Labs laser cutter over here. It is the Trotec Speedy 300. It's one of the best lasers that we have here. We have bigger ones. This is on the smaller side, but bigger doesn't always mean better. So I really like this laser, and I hope you will too. So today we're going to go through all the basics, the ins and outs of the laser cutter, and I'm going to be explaining everything as good as I can. So buckle yourselves in and let's go. So what is a laser cutter? It's basically a massive machine over here that has a laser in there, and it cuts anything that you put in there. Okay, not this one is only 180 watts. It only can cut plywood, plexiglass, some other stuff, but it cannot cut metal. That's out of the range. It is a CO2 laser, and it cuts comparing to the competition slowly. Of course, if you compare it to desktop laser cutters, it's industrial grade. It costs a lot of money, and it's really, really good. So, question is, what can you laser cut with this laser cutter? So, you can laser cut, of course, first you can cut a square, then you can engrave something on it, or you can cut something out like this, or you can even make living hinges like this, or you can make a battle bot. This is my one. I made this one. The art as well. That's not engraved, that's just paint. But yeah, you can make battle bots that can be smashed around and see, still perfectly all right. And you can go even further. You can make puzzles over here. This one is glued together with tape on the back, like this. Then we can also make not only living hinges, but we can make hinges by themselves. This is supposed to be a tree, a pine tree. It has a star. And even you can make bigger things with the laser cutter, like one of our interns have done. He has made a Minecraft pig. I crashed it. But there, see? Minecraft pig, like this. It's quite big, it's quite heavy, but yeah, it's made from the same stuff that we use here. Over here, 6mm plywood. This thing is made from the same thing, only bigger sheets. But yeah, can be opened, can be fixed, has wheels. Currently it's not turned on, otherwise I'm gonna crash way worse. Let's put it back down over here. But yeah, you can make big things, small things, very precise things with the laser cutter. So this is going to be crash course how to use it. Not abuse it, how to use it. So why should you be choosing the laser cutter instead of a 3D printer? Instead of this thing? This thing prints plastic, this thing can cut plastic as well. But what is better than a 3D printer is that 3D printers are slow. They're very slow. When you move the bed, when it prints layer by layer, it is slow. The laser cutter is fast. For example, if I would be cutting out this small box, it would take 3-4 hours. Okay, maybe on faster printers, maybe 2 hours to print. But over here in the laser cutter, it only takes few minutes. This one, to be exact, 4 minutes of cutting. Plywood, you cut it, and then I think this can be also, yeah, this can be somehow glued. It's glued? No, it's good. Can be disassembled like this. So it's basically plywood cut into pieces, glued together, and it's quite fine. It's very nice. So laser cutter can also cut small things, like tiny pieces of plastic over here, if you look at them. same as this. You can cut very precise things. For example, these snowflakes are supposed to be broken off. See, already broken off the piece, but it's still held in place. So laser cutters, in nutshell, much faster than anything, but it's limited to 2D surfaces. It can engrave some 3D surfaces. For example, we have a rotary attachment to rotate mugs and engrave them. If you cannot really cut anything like that, we cannot cut a mug. It's made out of porcelain or some clay, it cannot be cut. But it can be engraved. But the laser cutter mostly for 2D things. Later you can assemble them in 3D things. There are many things that are assembled layer by layer and then joined together. You can have some 3D things like this. Same as this tree. Looks completely flat, but can be made into a 3D object like this by bending. Plywood bends quite actually nice. I really like how plywood bends when you bend it. See, it's quite bendy. It's very nice material. I really like it. So, what do we use the laser cutter for here in Riga Technical University? Mostly, it is the architectural students that cut out these type of cardboard houses. They can also be from plywood, plexiglass, doesn't matter, but they are cut like this. So, instead of wasting multiple hours printing this is like 2 hours or 1.5 hours, you can be making this in a few minutes. Of course, you have to glue them together, but it's way faster. That's why most students prefer the laser cutter, because fast and cheap. This, if you find the cardboard, costs only a few minutes of laser cutting. This will be a few euros if you compare it like that. So most common cases, students will be using it to cut out something. So either small things, big things, things that conjoin together, or basically anything. But what's mostly used for laser cutting houses, laser cutting quick prototypes, the laser cutter is super precise, and the best thing, it's super fast. So most common use is architecture students, in some other cases, some other things. Can you spot the difference between these? Do you see them now? Or now? This one had the red or black glue. This one had the white glue. See the difference? Alright. Before we even touch the laser, let's talk about the materials which are safe to cut and the ones that you should never even bring near the laser. So, safe to cut material category. Jumping to the most common material, which is the interior plywood. This material is kept in stock in the lab in two sizes, 3mm and 6mm. And sometimes you might even find the 4mm remains that are left from the older times. The interior grade plywood cuts well and gives clean edges. All of the material that is stored in the lab's plywood scrap and full sheet shelves are interior plywood stocks and are safe to cut. Paper and cardboard. In most common cases, the students will bring their own paper and cardboard. They come in different colors, sizes, and thicknesses. Currently, almost all kinds of cardboards have their settings already set up on the laser cutter. But it's always recommended to cut out a small piece to test if the material cuts through even. Both paper and cardboard cut beautifully, but they are highly flammable. So use low power and keep a close eye on it to avoid flare-ups. Corrugated cardboard can catch up in flames in under 6 seconds because of the great airflow that the corrugated layers allow, and in rare cases the cardboard can burn from inside out, creating a big dark spot, so be really careful when cutting cardboard materials. Cork, the same material that is used for cork in bottles. They also come in sheets, and it cuts nicely with the laser. It's natural, safe, and gives great results for coasters or inlays. But the sheets may be badly warped, so be sure to tape them down as necessary. Organic leathers.
Real, untreated leather is safe to cut. Just make sure that it's vegetable tanned, not chrome tanned or synthetic. That stuff releases nasty chemicals. When leather is cut, it also smells like burnt meat, so it's not suggested to be cut in large quantities. Acrylic or so-called plexiglass. People call acrylic or plexiglass different things, but you have to remember the real name. Polymethyl methacrylate. In short form, PMMA. This material is also stocked in the lab, ranging in sizes from 2, 3, 4, 5, 6, and 8 millimeters. Sometimes you might even find 10 or 12 millimeter ones. And plexiglass, remember PMMA, is also one of the best plastics for laser cutting. It cuts very cleanly, polishes the edges as it goes, and smells a bit like sweet plastic. Avoid other plastics that look similar though. They might be not safe. Some natural fabrics are also laser cuttable. For example, silk, cotton, felt, and wool are fine. Just keep the power low to prevent charring. But synthetic fabrics like polyester or nylon can melt or give off toxic fumes. Avoid those. And then, polypropylene. It's one of the few plastics that is reasonably safe to cut. It tends to melt a bit, but it doesn't release toxic fumes like ABS or PVC. Other safe materials include wood veneer, MDF without exterior glue, natural rubber, and Derlin. These are generally fine in small amounts, but ventilation is always important. Now we have reached the do not cut material list. Exterior plywood. As in previous clips shown, the exterior plywood burns and it doesn't even cut through. It contains weatherproof glues and resins that give off toxic gases. Don't risk it. And this is one of the most misunderstood materials by the students. Be aware of these, and you must tell them apart. If the student says that the material has been brought from Home Depot or some other mysterious place, it's probably non-cuttable exterior plywood. PVC, or in the long term, polyvinyl vinyl chloride. Absolutely not. As its name already suggests, it contains chloride, which releases chlorine gas when cut. This gas is corrosive, toxic, and destroys the laser cutter's optics and electronics, and your lungs. This material should be never ever cut. Polycarbonate, or in its short form, PC. It looks like acrylic, plexiglass, but behaves totally different. It burns, discolors, and releases toxic fumes. It also barely cuts through. It is also one of the most misunderstood materials by the students. Always make sure to check the origin and markings on the material that is brought by the students. If you are not sure, suggest to use our material. Be sure to ask the staff's opinion, or tell the student that the material cannot be cut. Epoxies, fiberglass, and carbon fiber composites. These materials are resin-based and are full of glass or carbon fibers. Cutting these will release fine dust and extremely toxic fumes. Never use them in the laser. ABS. You probably know what's ABS. Legos are made out of ABS. In long form, acrylonitrile, butadiene, styrene is another no-go material. It melts instead of vaporizing and outgasses hydrogen cyanide, which is highly poisonous. Never cut this material. HDPE. High-density polyethylene. This material just melts in gooey mess and can catch fire. It is not worth the trouble. Food. Even though food is non-toxic, do not cut food. A laser cutter is not meant to have food even near it. Vinyls and fake leathers. They usually contain PVC, meaning chlorine gas again. Dangerous for you and the laser cutter. Painted or coated woods and metals. The coating can contain lead, chromium, or other toxic compounds that become airborne when burned. Yes, the filter almost filters everything out, but what remains on the material as dust stays there, so there's still possibility of inhalation. It is not worth the risks. Teflon, or in short form, PTFE, and other fluoropolymers. When these materials are cut, they release toxic fluorine compounds. They are super dangerous. A quick rule of thumb. If you are not sure what the material is made out of, do not cut it. Always check the manufacturer's datasheet, and even then, don't believe that it should be cut. For example, when making this guide, I found out that the laser cutter's manufacturer's website is advertising that the laser cutter can cut some of the dangerous materials. But in real life, not only they will poison you, but they will also corrode the metal inside the laser cutter. And when you're not sure and being pushed by the students to test out the material, be sure to ask the lab staff for opinion or don't cut the material. Nothing bad is going to happen when you do not cut the material, and in that case, suggest to use one of our ore materials that is kept in stock. And yes, students might get angry, because in some instances, the store clerk where they bought the material from tells that the material can be cut. Yes, of course it can be cut, but in reality it will not only poison you, but the people around you and the students themselves. So always be aware of the materials that you or others are cutting. Alright, remember to stay safe, and let's move on how to actually operate the machine.
The laser cutter assembly consists of four main things: the pre-filter, which we are currently not using, the laser assembly itself, the actual filter, which are we using, and the computer system. To turn on the laser cutting system, first you have to find the power button, which is located over here on the back of the laser. You don't have to reach very far, it's over here. Can you see it? Yes. To turn on, just flip the switch. The laser cutting assembly will turn and calibrate itself. Please. Turns on, it levels the bed, and then it will level the laser gantry itself. After few beeps, as you can hear, the laser cutter is ready to start working. It has calibrated all the 0 positions of the bed and the head. The work can be started. When the laser cutter is turned on, you can manually control it by the physical control menu that can be found here. There are many buttons. I'll explain each one of them. Over here, the main button that's currently yellow, this button controls the wake and sleep state of the laser. Currently, as you can see, the button is on, the laser is in sleep mode. If I'm going to press it, it wakes up the laser. And when you press it again, it puts the laser to sleep. If this button is turned on, all of the other controls do not work because the laser is in sleep state. Over here, this button is a laser manual button for the filter. If you press it, the filter is going to wake up. If I'm pressing it, the filter manually wakes up. If I'll press it again, the filter goes back to sleep. We don't really use this button because the filter automatically turns on when you launch the job. It's only here to check the filter if you want to do it manually. To the right, you can see the pause button. This button is used to pause the job. If you're doing something and you need to adjust something, when you press the pause button, the job will pause, and then you can adjust anything that you want, and when you press it again, it will continue the job. Over here, if you look at the lower side, you can see the main control buttons for the laser assembly itself to manually move it. If I'm going to wake up the laser, then you can see that over here, that these buttons, the red buttons, control the laser head. I'm going to move it to the down, to the right, back up. These buttons move the laser head. The buttons on the side control the bed. This button, if you press it, the bed goes up. If you press the down button, the laser bed will go down. Currently, I'm just moving it up. As you can see, it's slowly moving up. I'm going to move the laser here. So, back to sleep. Back to sleep. See, the laser goes back to sleep. These buttons, these are the shortcut buttons. This button represents the enter button. If you press this button, it will launch the job that is on the computer. We don't use this button because we always make sure that we launch the job from the computer, but this button can be used as a repeat button. If you, for example, have had a job and it doesn't cut through it all, then you can use this job button to launch the job a second time. Over here, this button represents the arrow up. This button is like a shift button. If you press this button, the laser assembly will go really fast to one side of which button you have pressed. For example, I'm going to hold the shift button, and then I'm going to move it to the side. See? It's really fast. If I move it manually, it's quite slow. For example, if I would like to take the laser head from here to that corner, and I would press these two buttons together, see, it's really quite slow. Let's go back, and for example, if I want to go really fast, and I don't want to hold these buttons for a long time, I press the shift button, press these buttons. As you can see, the laser goes back to place. I can do the same thing for this side. It goes like this, and then it goes back. The buttons can be pressed simultaneously to move it diagonally, but you can also use it one by one to control the laser assembly. Let's send it back to its place. And now it's back to sleep. This is the laser control menu. Before starting your job with the laser cutter, you must obligatorily check three things: the laser lens, the laser mirror, and the laser filter. Over here, I'm going to turn on the laser, move the head in the middle position, and turn it off. Over here, you can see the laser head assembly. Over here is housed the mirror. Over here is housed the lens. Over here is housed the pressurized air that blows down this nozzle to blow away the smoke. And over here is the groove for the calibration tool. And that's the whole laser head. To remove first the mirror itself, you have to remove these two screws. You have to unscrew them anti-clockwise. Do not lose these screws. Store them in safe place. Over here, be really careful to not drop the laser mirror. You can just take it out when the screws are unscrewed. I'm going to place it here. Over here, if you can see, it's a little bit cloudy. I'm going to place it here. Then, over here is housed the laser lens. To unscrew, there's a big screw on here, over here, and it's unscrewed anti-clockwise. So unscrew it, and then it can be slidden out. If you can see, it's also pretty dirty. It's very cloudy, and it's not see-through. You can see the cloudiness over here on the lens, like here. Place them over here. To clean the laser lens and the mirror, you have to use this toolbox that is stored over here on the laser filter. Sometimes it's in a different spot, but we store it over here on the laser filter to make sure it's in one place, and we all know that it's over here. So you'll need two things from this box. You'll need lens tissues and lens cleaner liquid over here. First, remove the lens tissues from the protective bag so no dust gets in there. Here the lens tissues and the laser cleaner. First, you have to prepare the lens tissues. You open it and you tear off one piece of lens tissue over here, like this. Then you have to fold it 3 times. 1, 2, and 3 times. It has been folded 3 times. Then, using the lens cleaner liquid, put 2 drops on the mirror. 2 drops on the mirror. Close the lid, put it away, and then swirl it around. You can see the liquid swirling around, very nice. And then, taking the tissue, put it on top, rotate the whole mirror 1 full rotation, and then press down and wipe away. As you can see, the liquid very quickly evaporates, and now it's very clean. Looking over here, you can see the mirror is like a mirror. There is no cloudiness in there. There are a few scratches, but that's just fine. You have to make sure that there is no cloudy film on it. Now it's very clean. Same with the lens, but the lens has 2 sides. Please, always, when you have used the lens tissue, throw it away. We do not reuse them again. So each side will get a new tissue. So again, taking the tissue, folding it 1, 2, 3 times, taking the lens cleaner, 2 drops on the lens, closing it, and again be really careful not to drop it, and then press it on, rotate it 1 full rotation, pressing a little bit, and then wiping away. As you can see, the lens top is now white clean. But we still have the other side, which is again cloudy. So again, throw this away using a new sheet, tear off a new sheet, fold it 3 times, 1, 2, 3. Again, 2 drops on the other side, 1, 2. Close it. And then really carefully swirl it around so the liquid gets in all places. Put it on, rotate it, pressing it slightly, and then again wipe slowly away. As you can see, it is now very, very clean. So both sides, you have to make sure that the lens and the mirror are clean. So let's put them back the same way. So as you can see, on the lens, it's written over here, top, an arrow indicating this way, and you can see the corners are cut off here, same as on here. You can put it in, slide it in, make sure not to touch the lens itself, and you slide it in, and then this can be rotated clockwise to lock it into place. Make sure to not over tighten. You can already see some people have used some pliers to open it because someone had over tightened it. You have to just tighten it, finger tight, so you can easily untighten it. But not too easy, you have to apply a little bit force to untighten it, so apply also a little bit force to tighten it. If you over tighten it, it will be impossible to remove. Please do not do that. So to check it, if it's tightened, you can put your finger and then just roughly moving. See, I opened it just by 1 finger, so it has to be put a little bit tighter. It's now a little bit tighter, and now it's impossible to open it with 1 finger. But if I use 2 fingers, I can open it quite easy. So just finger tight, make sure that it's not going to come off. Because if you tighten it a little bit loosely, then this whole thing is going to be wiggly and it can accidentally come out. And it will not give you a perfect result. So finger tight. Same with the lens. Now same with the mirror over here. Be really careful, you don't have to slide this, you have to put it on. There's no written top, but you have to, of course, mirror goes down, and then you have to look at these 2 corners that are cut off. These are very sharp, but these are cut off. So over here, same, also cut off corner, and then you can just put it on. Remember, take the screws. So screw in each place, and then you just tighten the screws. Again, make sure to do the finger test. If you cannot screw it with 1 finger, then it is good. Over here I'm going to untighten, see, with 1 finger putting quite pressure I can move it. So this is bad. You have to make sure that they're finger tight and also can be open, because please do not over tighten these. So hand tighten, it will be perfect. If these will be not tight, the whole mirror is going to shake and is going to make a lot of artifacts on the laser cutting surface itself. Okay, so lens are cleaned. Let's go to the next thing, the filter. The third thing that has to be checked. Remember, after cleaning the lens, place the lens tissues back into the protective bag to protect it from dust and other debris. And make sure that the lens cleaner is tightened to not spill accidentally in the box. After done, close the box and discard the used tissues. So, after those two things are done, let's get to the third thing, checking the filter. Over here, if you go back to the laser control, we press the filter button and then the filter turns on and we can see the filter condition. If it goes up, see it's going up. It's going to about 93, 94%. It's even going up and now it's going low. Now it's decreasing the speed. Is it going to go down? Okay, so the bigger the percentage, the fuller the filter is. This filter has to be replaced after quite early now because it's quite full. If it's going to 100%, if you increase the airspeed like this, then it might show 100% it will be. That means that the filter has to be changed. But now the filter is doing quite okay, so you just have to check the filter. Please do not use these buttons. These are not used to mess or anything with the filter. These plus and minus are just changing the air throughput of the filter itself. We don't really use them, we just have to set it at 100%, and it's just fine. We don't have to tune it. If something is wrong, I'm going to mess around with these. So, turning on the filter. So filter is okay, it's not beeping. The lenses are clean. We can get to the program. So, the laser has been turned on, the lenses and the mirror and the filter has been checked, everything is perfect condition. Now we have to turn on the computer. Computer usually is in sleep mode, so you can just mess around with the keyboard and it will turn on. In this case, messing around with the keyboard doesn't turn it on. So in this case, it has been shut down. To turn on the computer, the power button can be found on this right corner upper here. There's a button over here. Can you come here? The button is hidden over here. So pressing the button will turn on the computer. So let's wait until the computer turns on. So the computer has been turned on. We have to put in the password. The password is hidden over here. It is RTUDFLaser1. So the password is on the left bottom corner of the monitor. So RTUDFLaser1. The computer opens. We have to open two programs, which is JobControll and CorelDraw. So over here, we have already pinned the two programs. So first, let's open JobControll. JobControll is opening. And then later we will open CorelDraw. So why do we need these two programs? One program is to control the laser cutter. The second program is to control the vectors, the drawings, everything for the prep for the laser cutting. So two programs, one controlling the laser, other controlling the files itself. So JobControll over here has started. It will open. Sometimes it opens with different files. You have to close them. It's loading currently in everything, and it will say cannot position more jobs on display. Oh, usually this error comes out because the last person will close this program had left some jobs open. So we press OK, 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 OK. And usually some jobs appear on here, but in this case there's no jobs over here. So JobControll is open, everything is very nice. Let's open CorelDraw. CorelDraw is opening. You can open CorelDraw files directly. Usually it's suggested to open CorelDraw and then import the files in there. So these two programs have to be opened. So see, CorelDraw is open, and it will show menu screen. Do you want to open a new document, or do you want to open already document? If you press new document, you can choose a custom size, which is usually the laser size 730 by 430 millimeters. Okay, and basically this will open the laser size itself. Currently it's quite slow. Okay, see the laser bed. So the laser sizes can be found over here. We have printed them on the laser. Over here is written 735 by 435, but in reality, usually you have to do it 730. There's 5 millimeter difference.
CorelDraw and JobControll. When the CorelDraw program is open, on the Welcome screen, under the Get Started tab, you can open an existing document or create a completely new blank one. For our laser cutter, the correct blank document settings are as follows. Primary color mode set to RGB. Page dimensions leave the same as the laser cutter's maximum bed size. And remember to keep the units in millimeters. You can also do this by going to the top and pressing File, New Document, or Open and selecting your already existing document. If you're working on something important, Remember to give your project a proper name and save it somewhere safe so nobody accidentally deletes it. Avoid saving files on the desktop. It's frequently cleaned and things may disappear. Either create your own folder in the Documents tab, or save it to flash drive, or use the cloud. CorelDraw interface. When your document is open, it appears under a tab at the top, with all its pages listed below. On the left is the toolbar, which contains all the drawing tools. Some buttons have a small black triangle. This means multiple tools are grouped inside. Click and hold to open the group and choose the tool you need. On the top bar, you'll find options and properties for the current selected tool or object. On the right, you'll see various panels called dockers. The main you're going to be using is Properties, where you'll find options for the line color, line width, fill color, and texture. If any of the Docker panels gets accidentally closed, you can reopen it from the top, pressing the window, Dockers, and then choosing the Docker that was missing. Working with objects. There are three types of objects in CorelDraw. There are the vectors, the images/bitmaps, and text or annotations. Let's start with vectors. You might be asking yourself, why vectors? Well, for any laser cutter, vectors are really important because vectors act as a coordinate system for the laser cutter, defining paths with exact units so the software and physical cuts match perfectly in size and accuracy. Vector graphics are made up of points, lines, and curves defined by mathematical formulas. They can be scaled infinitely without losing quality. Most importantly, the laser cutter reads the vector paths directly. They tell it exactly what shapes and lines to cut out or engrave. Drawing basic shapes. To start drawing, enable the freehand tool and draw by clicking and dragging. You can draw squiggly lines by holding down the left mouse button, and straight lines by clicking in different locations. You can also combine squiggly and straight lines. Let's try drawing a light bulb. You can see that this tool leaves all of the detail and mistakes intact, and also you can see that the line ends can also be connected to different lines. Here's a very ugly light bulb. The polyline tool lets you drop straight segments with single clicks, or draw freehand by holding down the click. Double-click or close the shape to finish your drawing. For arcs, use the 3-point curve tool. Click and drag to define the base, then click again to set the arc. For smoother curves, use the Bezier, Pen, or B-spline tools. With Bezier or Pen, click for straight lines, or click and hold to curve the line using the tangent handles. With B-spline, click to place the curve points, and double-click to finish. To draw regular shapes like rectangles, circles, or polygons, use the tools between rectangle and polygon on the toolbar. You can draw uneven rectangles and ovals, but if you hold the Control button on the keyboard, you can draw perfect squares and circles. For polygons and other shapes, you can set how many number of edges you want in the Objects option menu found on the top. You can also use common shapes to select from preset forms. The Artistic Media tool allows you to draw freeform sketches and adjust the stroke style, width, and other properties. Let's try to draw a cat and adjust some options. Seems like it's a little bit angry about my drawing skills. You can also try Live Sketch or Smart Drawings to automatically smooth out your strokes. Managing your drawings. To move or scale shapes, use the Pick tool and click on any object. You can drag to move, Or use the black corner nodes to scale freely or enter exact values in the object size fields. You can also lock the aspect ratio to scale evenly or unlock to stretch in one dimension. Clicking on the same object again switches to rotate and skew mode. You can rotate using the corner handles or type an angle in the rotation box. Or if you want the object to be skewed, you can use the skew handles and drag them to skew the object. To rotate around a different point, drag the center crosshair to where you want the rotation to pivot. You can also mirror the object horizontally or vertically. Using the Shape tool, you can smooth out the edges of your shape by dragging the corner nodes, or you can indent or bevel them using the top menu. Drawing aids. CorelDraw provides rulers, grids, and guidelines to help you to align different objects. Drag from the horizontal or the vertical ruler to drop a new guideline. Use the mouse wheel to zoom in and out. You can also enable snapping from the Snap to menu. Snap to grid, guides, nodes, edges, midpoints, intersections, or centers. A great way to practice vectors is to create a three-dimensional box with basic connections. You'll have to think how everything will fit together in real life when the thickness of the material is introduced. Let's try to draw this example, and in the process we'll learn some handy tricks with shapes. With multiple different shapes and lines, you can combine them into a continuous line with the tools found at the top bar. You can see that the Well tool combines the shape with the outer outline, but using the Trim tool I get the result that I was looking for. I highly suggest testing the other tools to get the feel how each one can aid your drawing experience. Here I'll try to make the other linking side of the box piece. Be sure to test out your drawings by snapping them together and looking for sides that may not fit or disrupt the connections. We can see that one of the sides will have to be modified to fit together. To edit curves with the Shape tool, you'll have to check if the object is converted to curves. Simply right-click on the object and select the Convert to Curves option. Now I will attempt to substitute one side of the wall to the second one, and see if the box fits together now. Seems like there's some more details to improve. You can also use the Combine group and Ungroup under the Object tab or with shortcuts. And of course, you can use Ctrl+Z to undo something. Now it's looking way better. Let's try to copy and paste multiple ones so we can see how the box looks from all sides. I will also remove the top pieces to make a flush top. Alright, seems like all sides will fit nicely together. Now, what's left is to prepare it for the laser cutter. Editing properties. To prepare your design for the laser cutter, open the Properties docker. Under the Outline tab, you can set Line color to full red, in RGB values the red option 255, to set a true cut in the material. Or full blue, in RGB values 255 value in the blue option, to set just a surface cut in the material. Or full black, either leave the RGB values to 0 or all to 255, and use it to engrave something. Remember to set the line width option to hairline, otherwise the laser will engrave instead of cutting. Very important, the laser only reads pure RGB values. If you have any mixed or partial colors, it will be treated as a grayscale and engraved instead of cutting. Under the fill, you can apply colors, gradients, or patterns, but remember that it will be just engraved as an area. Working with images. Images/bitmaps are made out of pixels and lose quality when scaled too much. To import one, go to File, Import, and select your file, and click and drag to place it. You can move, resize, or rotate it with the Pick tool, and crop it or reshape it with the Shape tool. You can also use the standard crop tool to crop the image normally. To convert an image into vectors, use the Trace Bitmap option. This creates vector outlines based on the image. Simplify to as few colors as possible, ideally black and white. You can also adjust the detail of the image, smoothing, corner smoothness, and some other options. Since the image now is converted to vectors, you can go into the Properties panel and remove the fill of the model and create a specific outline of the color you wish to engrave or cut. Just remember, if you're surface cutting multiple lines together, or there are double lines that overlap each other, you can accidentally almost cut out through the material. The easiest thing to do is to take black and white images and then converting them to vectors. This will turn the low quality raster image into vectors and you can laser cut them out really easily. Now let's try to recreate this black and white Mr. Bean. As previously mentioned, you should aim for the least amount of colors as possible, perfectly black and white. But in this case, I'm going to try to use some of the gray tones and then later delete them. Use the Text tool to create text boxes by clicking and dragging. If your text exceeds the box, the outline will turn red. Just resize the box to fix it. You can move, rotate, or skew text using the Pick tool. Edit font, size, and color from the top bar in the Properties panel. To change text fill, background, or outline color, remember to have your text selected. Be sure to test out all the things in the text options. There might be some things that might come in handy later. For example, text positioning, text fill type, text organization, all the possible sizes and styles, and of course, the color and the outline of the text. You can also turn the text into curves using the right-click menu. Also, if you get annoyed by the text outer box, you can disable it by converting the text to artistic text. Now let's look at some laser cutting examples. Here we can see the standard text being engraved with the black fill, and here we can see the surface cut with the blue line. You can also combine these two methods to increase the visibility of the text. Of course, nobody is keeping you away from cutting out the text, but the results may vary because the inner parts of the text may fall out. Opening and editing files. Now that you know the basics, let's open a test file and prepare it for laser cutting. Simply go to File, Open, and select your document, or in the File Explorer, right-click on your file and choose the Open With and select CorelDraw. The supported formats include .pdf, .cdr, .svg, .dxf, and .dvg files. When importing, for PDF files, select curves. Or if you're opening a DXF file, check the scale settings carefully, because the imported size can vary. After importing, measure the key parts to confirm the correct scale. For cutting, remember to set the line thickness to hairline and make sure that the cut lines are perfect RGB red color. Remember, if you've set all of the outlines to red, they're going to cut out, even text. So in this case, I've also selected the text accidentally. Let's fix it. If the file is assembly of different pieces, be sure to check the group size. In this case, it checks out with the 6mm plywood. Delete any unnecessary lines or text. If engraving lines are too thin, you can change them to the RGB blue color. For surface cuts, it will make the cutting faster and cleaner. Remember to check for duplicated lines. They look a little bit thicker than the other lines when zooming in and out. If so, move the line slightly to see if another line is underneath. If so, delete the duplicate. Otherwise, the laser will cut the same line twice and burn the material. If you're working with multiple parts or vectors, arrange them efficiently in one sheet if possible, leaving at least 1 mm of spacing between the objects. Here are some examples. In first example, you can see that someone tried to do it, but there's still big gaps between the objects, and in the second one, you can see that it's arranged very nicely. But if you look close enough, you will see that some of them overlap, so that's the no-no. But in our case, the parts are very big, so we're going to be using the scrap material. I strongly encourage for your projects to use scrap material. Otherwise, if using full sheets, we are going to create even more scraps. So let's reuse all the scraps that we can. When everything looks correct, remember to double check. And you're ready to send the job to the JobControll program. Select the parts that you want to be cut or engraved, then go to File, Print, or use the Ctrl+P shortcut. Print options, very important. When the print window is open, you'll see a preview. If it looks cropped, don't panic. In print range, change it from current document to selection. Now it should only show the selected objects. Now click the gear icon to open the job settings. Make sure that these options are set correctly. The bed size should be 730 mm by 430 mm. And make sure that these two checkboxes are checked. Sometimes they uncheck on their own, causing errors later. So remember to double check them. If they are not set correctly, uncheck the checkboxes, set the correct size, and press the JC button to save the value and open the job settings again to recheck the checkboxes. This is one of the weird kinks of the software that you have to be aware of. When the values are checked and set correctly, we can move on to material settings. Under the Material Settings tab, choose the correct profile for your material. For all kinds of cardboard, you can use the Cardboard or the Paper tab. For plexiglass, use the Plastics tab. And for plywood, use the Wood tab. You will find all kinds of sizes for the specific material. Make sure to measure your material thickness and choose the appropriate setting. For this example, we are going to be using the 6mm plywood, so go to Wood and choose 6mm plywood. When the correct material settings are selected, you can press the JC button to confirm. And this very rarely happens, but if your job is not positioned in the center of the page, you can go to Layout and choose the center of the page option. But this happens in very rare cases. But I'm showing you this just so you know how to fix it if this happens. And when you're ready, you can press the print button, and do not worry, this only sends the job, it doesn't start cutting yet. JobControll. After a short transfer, the job should appear in JobControll. If you're still in CorelDraw, the JobControll icon should start flashing orange. Open JobControll and your file should show up on the top of the list on the right side. Before positioning your job, check that the laser cutter is connected to the software. On the lower right side, you'll see two indicators, ready and filter. If the two indicators are red, you should see a connect button in the shape of a USB. Press the connect button to initialize connecting. The laser should start beeping and a status window will open. Once the laser is connected, the connect button will turn to play button, and the crosshair of the laser should appear on the screen. Usually the crosshair should appear on the top left corner. Because the laser calibrated there, you can manually drag the laser head to the middle of the bed using the laser control panel. The crosshair on the screen matches the real-life position of the laser on the laser bed, and you have to use it for positioning. If you select your job, you should see the job preview. If not, enable the job preview checkbox to see the job's layout. If your job isn't on the top, sort by date. When you find your job, drag it onto the bed view or double-click it to place it on the top left corner automatically. By default, your job appears gray. This is for positioning. If you want to see your job, press the eye icon on the top to switch to the line view. You can drag your job and snap it to the laser crosshair to match your material positioning. Material templates and color order. Open the Material Templates tab from the top menu. Over here, you'll find the same material list as in the print menu. Plus, you'll find the color processing order. The color order goes from the top to bottom. You will see that the black color goes first, then comes the red color, and then only the blue color. If the color is set to skip, the laser will skip the color and go to the next color. Each of the colors can be set to engrave, cut, skip, or position. The engrave option engraves anything that is black or in grayscale, even lines, and is often confused as the surface cut option. The cut option can serve as a true cut or a surface cut option, and that depends on the speed of the settings. The skip option, as previously mentioned, skips the color and goes to the next one, and the positioning option goes over the same path but without the laser, so you can use it for positioning. But no one really uses it, because it's way faster to go over the line yourself with the manual controls rather than using this setting. As previously mentioned, we use the blue color for surface cutting and the red color for true cutting, but these both options have to be set to cut to each do their thing. Do not change the specific color settings, they're optimized for each material specifically. If you need to experiment with a specific material, you can go to the Test Profile tab and create a new material template to experiment with the material you wish to. Remember to give it a proper name and a description for what purpose specifically the settings are for. It's recommended to skip the red cutting color and first only engraving the black and blue colors, because while cutting, the material might warp and ruin your engraving. Later on, you can skip the engraving process and only use the cut option. But for plexiglass, use the cut line first, then remove the protective film layer from the plexiglass, and then engrave on the exposed plexiglass. Otherwise, you'll be engraving on the protective layer and it will be impossible to remove and ruin your drawing. When you have selected the order of colors that you wish for, you can press OK and review your job. On the left side, the Calculation tab shows the color order and the estimated cutting time. Click Update to refresh times for your current file. Positioning and testing. There are some tools which might come in handy when managing your jobs on the laser plate. They include Rotate Job for easy job rotation on the spot, Vector Ordering, Vector ordering is usually used for bigger jobs to optimize the cut paths. Simply press the button and then select Quick Ordering and override Job box. Then click Start to optimize your vectors, but usually the optimization is negligible. So I suggest using this for bigger jobs, or in cases where the laser goes in random paths and takes a lot of time to travel from each to each. There are also marker options for alignment or multi-step jobs like acrylic engraving in layers. Use this option when you already have cut out a job and you want to edit your vector file. Without changing the file size, you will be able to engrave in the same spot as the job is cut. If you accidentally double-click on the job, it switches to the full preview and it's pretty confusing. To exit, simply press the Escape button on your keyboard.
Okay, now we have finally finished editing the file for the laser cutter. Remember to check the dimensions for your file. We have selected the special region as we did in the program, and grab your tape measures and go to the scrap wall first before going to the full sheet wall. So go to the scrap wall, your tape measuring unit, and then start finding the special size. So we needed about 13 centimeters in height and the length about of the laser cutter itself. So let's see, do we have any scraps of that size? No, that's too much, or that's too little. This is only like 4. And how about this? Oh, this is 14 and clean length for the one 730. So look, whoops. So 14, we can grab this. This will be usable. So we don't have to use from the fresh sheets. So put it into the left topmost corner very carefully, and then see if the material is warped. You can see that over here it is a little bit warped. So let's see what happens if we put it the other side. Because if you have it warped in the middle, then it's very bad. But if you have it warped on the sides, oh, over here it's not so bad. Only a little bit here you can see it's a little bit moving. So if it's warped on the sides, then you can fix it by tape measure. No, by Scotch tape, paper tape. You can just tear off a piece and just glue it onto the side. Make sure to stick it quite well, and same thing on the other side. Make sure that it's like really taped down, otherwise it will go off. If you have, for example, like really warped sheets, like something like this, then be really careful. If you manage to glue the corners down, then they might just pop off after some time. So be really careful about that. So that's why you always watch the laser. So we have taped down the corners, and if you just tap it, you can see, okay, this corner is moving a little bit, but over here it is fine. So calibration time. This is the most important time. To get a perfect laser cut, to actually cut through the material, you have to calibrate the laser quite well. So wake up the laser, go about in the middle of the material with the laser head over here, where it's the most calibrated, and then come here. We have to use the calibration probe that is hidden in here. Over here, this laser has a manual calibration probe, so we have this little calibration probe. Let's put it to sleep. If you look at it, you have a fatter part over here and a very thin part up here, and you can see the red nib over here. That's the part where you hold it, and a little square that you have to put into the laser head to calibrate. So carefully put it over here, so it just is still like that. And wake up the laser. Okay, when you have put it carefully on here like this, remember not to put it under this screw, otherwise it will get stuck. Make sure it's here nicely on the outer end. Of course, if it's going to be on the outer end, it might fall off. So over here in the middle, and then just tap you can hold the bed button to go up. And when you get near it, release and start just tapping a little at a time. So see, it's like tiny increments until it reaches so far that it falls off more and more. You see it moved and it falls off. This means it's perfect calibration. If you move it a little bit down, for example, demonstrate that you would be holding it like this. See, it fell down, but I managed to stop it in time. But if we do it again, it might go a little bit more. So I'm holding and it sees fast, but it still moved a little bit too much. So this will be a bad calibration. So you have to be really careful. You have to just, when you get close, just tap it so you have perfect calibration. So we have to remember that over here is the cut part. This is empty space. We have to watch out from this part. One of the good reasons that we taped it up on the corner is that we know that over here it will be good area to cut, but it's still recommended to leave the laser over here at the edge of the line so you understand what will be the limit. So I'm going to leave it here. Now the laser has been put in the right place, and in the program you can see that current placement is already interfering with the laser head, and we know that under the laser pointer is free space. So we don't have to cut in there. We must make sure that we don't cut in there. So let's move it a little bit upwards and keep like a little distance from the corners. Remember, we put the tape there. Let's give it some distance so we do not cut the whole tape. And if you can see, we have free space over here. It will be also showed in the screen recording. So it's over here. We can turn on the laser and check. Come here. So if we move from here to here, the same thing will also be seen in the program, that we know that above it's very nice and below there is empty space, so that we don't accidentally cut it. So it's recommended to go like this from one corner to the other corner and then go up and see if it actually interferes or no. But over here it seems fine. So now we can actually launch the job. So if everything is ready, everything is positioned, everything is checked, all the colors are correct, all the times are updated, and now you know how long it's going to take. It's going to take 9 minutes to cut and engrave these, but it's going to be fine. So we can press the launch button and the filter will automatically turn on. Please look at the filter. I'm going to start it in 3, 2, 1. See, it automatically turned on. And currently, let's go here and we can see the engraving process. It has finished cutting. When the laser cutter has finished cutting, make sure to take the head and put it to home position. And then you can take your parts out. But before that, put the laser to sleep. Then you can take your parts out. Be careful not to lift the whole bed with the tape, because sometimes, see, it sticks quite well, so carefully unstick it, remove it, then remove your parts if some are stuck, and then discard the pieces that are smaller than 20 by 20 centimeters. This one goes into trash, this one goes into the treasure. To dispose of the scraps, you must break them into smaller pieces. To do that safely, use gloves and safety goggles, because the pieces might fly into air and into your eyes, and these things pointy and sharp. So use gloves, safety goggles, break them into smaller pieces, and then they can be discarded into the trash can. This one is for scraps and materials. It's written here. Again, take the measurements from CorelDraw. 306 millimeters, a little point there. Let's find something that size. Ta. Pum pum pum, pum pum, pum pum. No. 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 If you cannot find any usable pieces that meet your size requirements in the scrap pile, then go to the full sheet stockpile that's over here. Check if there's any started sheets on the top. There seems to be only fresh ones, and I already know the size, 430 by 730. No used 6 mil, so let's use a fresh one. Carefully place it in. Again, check if there were. This one is fresh, a little bit over here, so I'll use a little bit tape to secure it down. Since we were using 6mm settings and they cut perfectly and the calibration was also fine, we don't really have to recalibrate. If we want to, we can. In this case, let's leave it. Since we already set the settings into the CorelDraw before in the print menu, we don't have to reset them again. We can just select our part, select selection, press print, and all the settings should be saved. And then in CorelDraw, in JobControll, we press the old file, can press backspace to delete it, and drag in our new file. Again, remember we have put a little bit of tape there. Let's leave some edge. Let's update it. Let's see with the eye. Everything seems fine. We don't have to check if it fits or not because it's full sheet. We can just if you see the laser cutter filling up with smoke like this, and it's not getting properly sucked, that means that the filter is clogged. But before you panic, you can press the pause button and pause the cutting, and it will slowly take all the smoke out. Do not lift the lid. If you lift the lid, all the smoke will go out. So let it recirculate. When the smoke has disappeared, you can continue cutting your job, but tell the lab's manager that the filter has to be replaced or the settings on the filter are bad. In this case, come here, we specially put the filter speed very slow and it is not sucking anything. So back to 100 and it will be fine. The big piece also has finished. But kind of is in the same place. It doesn't come out. In this case, 6mm plywood can have like branches and stuff. You can see some bigger branches are removed and replaced by the false oval of wood. But in this case, if you look at the other side, there are some small places where it hasn't cut. If it's not severe, you can try to break it out. If it's severe, then you have to re-laser it. And if you have actually placed it like correctly into the corner like this, you can actually make sure that you can actually re-laser that. If it's somewhere this, you will never place it in the same time. But if you place it in the corner always in the same way, you can try to re-laser it. But if you re-laser, the marks will get quite bad and there might be a lot of reflection from the bottom of the laser, so it might get very nasty. In this case, you can see everything has mostly cut out. The small things can be cut out with a knife, or in this case, you can just do it like this. if you take a look over here, this part is also coming out quite nicely, but these ones are not quite nice. As you can see, I pushed it from the correct place, no, from the correct side, because if I would have pushed it from the other side, all of these scrap pieces would have broken pieces over here. But in this case, they are like here, and this stayed in the same place. So there's nothing going to be damaged on this piece of wood. So let's get cutters and let's cut it correctly. Be careful with sharp things. Do not cut yourself, and just see where the line went, or look in the program and then just take the cutter and cut it in about the direction that it came from, like this. Make sure that the offcuts go into the scrap piece that is left over, like this, like that, like this, a little bit more. Over here seems fine. You can barely see the line over here, so let's cut it like here. You can see this line, so I'm going to cut it like this. A little bit more. Same here. This one is a little bit more difficult. Cut it like this. Okay, let's see. Did I manage to do it? Pulling it down. Okay, this one came out nicely. This one did not as well. Okay, this one is nice. You can use the knife to make it a little bit more nice, but be really careful not to cut yourself with the knife or with the sharp pieces of the wood. So just carefully take all the scrap pieces off. In this case, looks actually pretty nice. This one, I made a little mistake, but that just happens with 6mm. 6mm, you know, more sides, more sheets together. You know, 6mm, you have to put 1, 2, 3, 4 or 5 sheets together of plywood, and there can be a lot of branches hidden in there. So, yeah, in those places where branches, and the laser cutter did not cut them off. Can you see the branch? Yeah, over here, if you come close. If we tear this piece open, you can see over here, there has been a branch over here, and it hasn't cut out through the branch. You can see this darker part is the branch itself. It doesn't cut through the branches. So yeah, be careful of the branches. Let's put it together.